So if we are starting with an initial angle, theta equals 13 pi over 6. Let me erase a little bit of this.
Yes, there you go. It's late reaction.
It really freaked me out.
So we do.
I know.
It's most words staying.
Okay, I do want you guys to sketch this.
Okay.
Yeah.
I'm here. I'm here. I mean, I'm here, but I'm not.
Okay, so all of these angles, we will in a second. All of these angles are going to start. It's going to have its initial side in standard position. Can't really tell that I drew the side here. So there's its initial side. And then for now, you guys don't exactly know where radian measures are going to end up, like you might be able to guess degree measures. So for now, you're just going to have to trust me that 13 pi over 6 is right here. Whoa. Well, I just drew a line.
What are they called? No, the half circle.
Protractors? Not really. Okay, so if this angle measure is 13 pi over 6, add or subtract 2 pi to obtain a coterminal angle. So let's do one in both directions. So we've got 13 pi over 6. We're going to add 2 pi. We'll do that first, and then we'll do one where we subtract 2 pi. Huh? Just this. Okay. 13 pi over 6 plus 2 pi over 6. In order to be able to add these, they need to have the same denominator. So we need this 2 pi to have a denominator of 6. Right now it's 2 pi over 1. Yep. To be able to get this 1 to become a 6, we'd have to multiply by 6. And if we multiply by 6 in the numerator, we need to multiply by 6 in the denominator. Yes. So the 13 pi over 6 is not changing, but 2 pi becomes 12 pi over 6. So now, since these have the same denominator, we can add 13 pi plus 12 pi is 25 pi over 6. 25 over 6, we can't simplify, so it just stays 25 pi over 6.
Okay.
Yes.
When we look at where it says 13 pi over 6, how do we envision that on our graph?
You don't yet. So if it were in degrees, you might be able to visualize where that would be in reference to, if a full circle is 360, you'd kind of know where.
Did we just find out how to convert it?
Yeah, you could convert it if you wanted to. But for now, I'm just telling you that that's where it is. You just have to trust my word. Okay, let's find another coterminal angle, but we're going to subtract. So we can use the work that we've already done, 13 pi over 6, but now we're going to subtract 2 pi, which we already converted to 12 pi over 6. So if we were to subtract a full rotation, we end up with pi over 6. I just skipped this first step because we added a full rotation and got this coterminal angle, 25 pi over 6. You can also get a coterminal angle by subtracting a full rotation, but I just went ahead and used this 12 pi over 6 that we got previously.
Wait, but how can you add or subtract it?
What?
It's just like the picture that I drew where,
Is this the negative one? Are you saying that this, like the first one that we did is one that's on like this, and the other one the opposite?
I just-
When you add, you're getting like counterclockwise.
Okay. Number 2, we're starting with the angle theta equals 3 pi over 4. And we want to find coterminal angles.
What's the importance of theta?
It's just like if yeah, like x equals this, but theta is most commonly used for angle measures.
X, what, and
Okay, 3 pi over 4, starting from our initial side in standard position. 3 pi over 4 is like over here. Because I have memorized the unit circle already.
Just trust her that it's two.
it's like, there was
You will learn it soon, but not right now.
like.
Huh? Yeah,
What, Taylor?
yeah, you'll memorize the entire unit circle. It's like 50 something pieces of information.
Yeah, no.
We gonna have to use Excel?
Huh? No.
Uh,
Okay, if we're starting with 3 pi over 4, how can we find a coterminal angle? Says it right.
You add 2 pi.
Okay, so let's plus 2 pi.
3 pi, oh, that's wrong. You gotta make the denominators the same.
Yes. So what do we need to make the denominators? Good.
Wait, no.
So right now this is 2 pi over 1, but we want that denominator to be 4. So we need to multiply by 4 over 4. So we changed 2 pi to 8 pi over 4 so that now we can add these. 3 plus 8 is 11. So we have 11 pi over 4. Whoops, that should be equal sign. Right, 11 over 4 can't be simplified, so 11 pi over 4 is one of our coterminal angles. So now we're subtracting 2 pi, which we already know is the same as 8 pi over 4. And what do we get? Yep, negative 5 pi over 4. So we got 2 different coterminal angles. Okay, let's look at number 3, where theta equals negative 2 pi over 3. So we're going to start again in standard position. Negative 2 pi over 3. I think it's here. I think the negative ones are harder. So we rotated clockwise to get a negative angle measure, negative 2 pi over 3. But it doesn't really matter whether the angle starts as positive or negative. We still do the same thing to get the coterminal angles. So let's add 2 pi. Good. So we need to multiply by 3 over 3 to get the same denominator. So we got negative 2 pi over 3 plus 6 pi over 3. We get 4 pi over 3. Can do the same thing or get another coterminal angle by subtracting 2 pi, which we know is the same as 6 pi over 3. Negative 2 minus 6 is negative 8 pi over 3.
Nice spell with that. I don't really work to do that. I think I'm just getting tired.
Yeah, I'm stuck here.
Mine's starting to look really, really good, and I'm not tired of it. That's the same pattern I'm always.
Does anybody have questions over these examples? So if you're asked, or if you're given an angle measure and you're asked to find 5 coterminal angles, you wouldn't necessarily have to add 2 pi and subtract 2 pi. You could add 2 pi, then add 2 pi again to get a second one, then add 2 pi again to get a third, and continue adding. I just did add and subtract to show you that you can do either one. You could subtract 2 pi and then subtract 2 pi again, and then subtract 2 pi again.
You add one and then you subtract one and that's it.
Right.
You could just add it
Yeah, there.
twice and that can be 2 different.
Yep.
Always.
Yes, it's always 2 pi because you're adding a full rotation each time. And a full rotation, which is 360 degrees, is 2 pi always.
Say that correct scenario.
If you're gonna lap her again, would that be 4 pi?
Yes,
And the more they lap,
it just goes up by 2 pi every
instead of
time.
just keep going like 2 pi, 2 pi, 2 pi, you could just add them all together like 6 pi.
Right.
Oh.
Yep, you could. Okay, let's continue on and look at complementary and supplementary angles. I think this should be something that you've at least seen before in geometry. Probably. So 2 positive angles are complementary or complements of each other when their sum is 90 degrees. So 2 positive angles add to be 90 degrees. That means they are complementary. 90 degrees in radians is pi over 2. So 90 degrees or pi over 2 radians. Two positive angles are supplementary or supplements of each other when their sum is 180 degrees, which is pi radians. So really quickly notice these 2 angles that either are complements or supplements of each other must be positive angles. So we're eliminating any negative angles in this. There's not really another reason for that other than that's just the definition of complementary and supplementary. Okay, let's do some examples. I'm going to do one of each. I'm going to do the 72 degrees and the 2 pi over 5, and then I'll let you guys do the other 2 on your own. So we're starting out with an angle measure of 72 degrees. We want to find the complement of that, the supplement of that, and we also want to find a coterminal angle. So to find the complement of 72 degrees, the complementary angles add to be 90 degrees. So the way we can find the complement is by taking 90 and subtracting 72. Yep, 18 degrees. Okay, so how would we find the supplement? 180 minus 72. Which is what? 108? Okay, how can we find a coterminal angle? We start with the original angle, which is 72. We can either, would we add 2 pi? 360. Yeah. Oh, that would be 432. I think. Well, it's because it's what you've dealt with your whole life. You've never done anything with radians. Okay. So all we had to do is find one coterminal angle. So we're just going to stop there. Actually, I'll just do all of these with you. So let's look at 148 degrees. To find the complement, we start with 90 and subtract the angle. What's 90 minus 148? Negative 58. Is that a coterminal angle? I mean, a complement? It has to be positive. Does not have one. You can, yeah. I'll say no complement. Okay, to find the supplement, 180 minus 148, 32 degrees. And then how do we find a coterminal angle? So 148 plus 360. You could also do minus 360, but doesn't matter. You could,
Because it can be either one.
yeah, you could either add or subtract a full rotation.
708.
708,
508.
508. Huh? I know. Someone told me 7. I trusted them.
That's why you never trust me. I don't know.
That's why I never trust me.
Listen.
I don't trust my mental math always either. Okay, the next one, we're looking at radian measures now, 2 pi over 5. So how do we find the complement? What is 90 degrees in radians?
Pi over 2.
Pi over 2. Pi is 180 degrees. Whoops. So we're starting with pi over 2 and subtracting 2 pi over 5. But we need these fractions to have the same denominator before we can subtract.
Multiply 2 pi over 5 by 2 and then pi over 2 by 5.
Good. So we're going to multiply this fraction by 2 over 2. Multiply this fraction by 5 over 5 so that both denominators will be 10. We've got 5 pi over 10 minus 4 pi over 10. Five minus 4 is 1. Pi over 10. Yep. We want to find the supplement. So we need to start with 180 degrees as a radian, just pi. Pi minus 2 pi over 5. So again, we need the denominators to match. Yep. Multiply by 5 over 5. We get 5 pi over 5 minus 2 pi over 5. 3 pi over 5. Coterminal angle. Okay, we want to subtract 2 pi this time. Okay. If you want to add, that's fine too. But we need 2 pi to have a denominator of 5. So we need to multiply by 5 over 5. So we've got 2 pi over 5 minus 10 pi over 5. Negative 8 pi over 5. Okay, last one, 4 pi over 5. How do we find the complement? Pi over 2, which is the same as 90 degrees, minus 4 pi over 5. Make the denominators the same, which again, it looks like 10 is going to be what we need to aim for. So multiply by 5 over 5, and then by 2 over 2. We get 5 pi over 10 minus 8 pi over 10. Which gives us what? Negative 3 pi over 10. Yep, because it's negative, there is no complement. So just comparing here, 148 degrees, because that's bigger than 90 degrees, we really wouldn't even have to do this work. We could just say there's no complement. If an angle measure is greater than 90 degrees, it's not going to have a complement. Same here, 4 pi over 5, if it's bigger than pi over 2, so if you look at this fraction, 4 over 5, 4/5, it's pretty obvious that that's bigger than 1/2. 4/5 is bigger than 1/2. So we could just already say no complement without really even having to do any work. And our reasoning would be because it's bigger than pi over 2. All right, let's look at the supplement for this angle. So we're starting with pi, subtract 4 pi over 5. We need pi to have a denominator of 5, so we need to multiply by 5 over 5 to get 5 pi over 5 minus 4 pi over 5, which is what? Just pi over 5. All right, to find a coterminal angle, we start with 4 pi over 5. You want to add or subtract? Add 2 pi. We need 2 pi to have a denominator of 5, so we need to multiply by 5 over 5. 4 pi over 5 stays the same. We get 10 pi over 5. 14 pi over 5. If we could simplify that fraction at all, we would go ahead and do that, but we can't here. So 14 pi over 5 is our answer.